but I need to share my screen. Okay. I don't know what one. Go back. Okay. So, do you have any question from last lesson? From the first lesson? No?
The installing of like the linking between Qt and Visual Studio didn't happen correctly for me and Artem.
Yeah, I cannot.
Okay.
Install not connected.
You use the same links that I shared
Yes,
with you?
you said to install for Qt the min.gw pack, but just that one I cannot add in Visual Studio, but other ones I can.
Okay, we will check then after the
Yeah, and I already have Visual Studio 2022 on my laptop, so I want to know if it was possible to link the Qt with this.
We need to check. I never worked with 2022, but there should be a way. Yeah, there should be a way. But by the way, you can in every PC you can have different version of Visual Studio installed, so you don't have to stick to that one. You can have multiple. Okay, then at the end of the class we will check that one. Hello. Good morning. What time is it? Okay. Did you choose about your projects? Which projects you want to do? Your team member? Anime?
CD.
Okay, let me check. Probably you sent it to other email address. What? How can I search it? What was the Sydney?
SIDY.
SIDY. This one? Okay, but how come I didn't see it? Learn influence on HTTP with C++. 3 braces. Okay. We had last year, there were 3 people in the team and their name starts with KFC and their name was KFC and I still remember that. So. Okay, cool. And who is CD?
He's sick.
Okay, and Artyom. Am I pronouncing correctly?
Yes.
Okay, Artyom. And Kian?
He's
or?
on his way. He's not.
Okay. And how do you pronounce his name?
Kian.
Kian. Okay.
Okay.
Okay. Let me check. And you already joined the group that we had on Canvas?
No, not yet.
But it would be great if you also do.
I thought the Canvas was not active already.
No, I sent you 2 announcements there. The links for downloading those softwares. And the second one is the material where you can find the material of the course.
I have the site, but not the Canvas page. So the groups.
I can also check it here. I think it's Chrome. Just work. So then you need an HTTP. Okay, I will bring that next week. The device you need to work with. Where is that? Hello. Good morning. No problem. Okay. Yeah. So in the announcements, we have two. The first one is the software that you need to install on your PC. And the next one is where you can get the slides. I created a new page for this year such that I can put the videos and the slides together. Also, the project definition is there. You can open it. So the project definitions you can find, it will take time. We are at PUE with the very fastest speed internet. So this is the project definitions. You have them here, the video recordings and the slides. The slides of all the lessons are already there, but whenever we record a lecture, I will also upload it on the website. But you can still have access to the video recordings of the lessons in the chat section of our meeting, I think, if I find it. In the chat section, I think. Yeah, you see the videos are also there. So either from here or from the website, you can access to the video recordings. I always download it from here and then put it on the website, so they are the same. What else? Yeah, I think it's that. You have and we always use the same link to join the meeting. What else we had? And the softwares. Every year, because there were sometimes, for example, some of the links for these queues will be deprecated, or there would be a new update. I had this problem also last year, and you had to disable the updating thing for Qt, such that you are safe. Otherwise, when it gets updated, then the mismatch will happen between the version of Visual Studio and the Qt. But let's check it at the end of the class together to see what was the problem. Okay, I think we can start. Okay. Last time we learned about what is C++, what is the relation between C++ and object-oriented programming. We wrote a Hello World program in Visual Studio. We learned how to work with, how to build our project, how to run our projects. And we learned about different variable types, constants, enumerated constants. We wrote a piece of program to learn about enumerated constants. And today we will learn about expressions, if-else statements, conditional operators, switch statement, functions, recursive functions, loops, function parameters, and arguments. So the first thing is that, okay, what are expressions? Expressions are the things that you write, for example, in math, and then you can run them and see the results. So we have 5 mathematical operations here: addition, subtraction, multiplication, division, modulus. These are very similar to the operators that you have in any programming language, like in Python and other things, with very minor differences. So here, variables may, as I said last week, the variables can underflow and overflow depending on their data type. So if, for example, for integer, if you set the variable to a number that is lower than the range that it accepts, okay, it will underflow, and the value that you will have there will not a correct value. And also, if it's bigger than that range, outside of that range, then it will overflow. But this okay, you as a person who is developing the code, you know that, okay, you will not assign such a number, such a value to there. But with your calculation, you may reach those situations. So you should be careful, okay, if I'm doing this multiplication, if it can still fit in integer or if it can still fit a short int or something. So you need to choose your data types correctly such that you will not have underflow and overflow with your calculations. So this is a very simple one, a plus b, the result will be set to x. But in C++, you can have some situations like this. A plus b will be a number, will be set to x, and x will be set to y. Okay, so you can have them step by step. So if I here, we said that, okay, auto is a modifier, a data type that we like to use, okay? And we said that, okay, the data type will be defined by the type of the value that is set to, okay? So here, 21 divided by 4. We have a division operator, but 21 and 4, both of them are integer, okay? So division would be, again, integer type. So the result would be 5. Despite the fact that it's not 5, the real result is not 5. But since both of them are integer, the division will be also done in as integer. D will be also an integer value, the variable. How about here? We are putting there 4.0. So now we are saying that it's a floating number. Okay, so the division will be done like in a float or double, and normally auto choose it as, I mean, it depends again on the compiler, as I said last week. So normally it's double, and then it would be 5.225, yeah. So, and df would be double, so it would be double variable. So, but you need to be very careful. So when you are writing your formulas, you should know that, okay, if you don't write it as a float, or if there is no variable here of type float or double, then your results will not be correct. Okay. Incrementing and decrementing. So in C++, you have these operators to increment your variable by 1. You can also do decrementing with minus minus. Okay, so the variable counter will be added by 1. So all these three are similar. But okay, this one and this one are more readable. For me, I normally prefer even this one. So it's very readable compared to this one. You don't need to rewrite the variable name again. But if you see these three, they are equivalent. How about here? Do you have any idea what's happening?
I know when you write the pluses before the variable, it does it before, and when you write them after, but it's weird when it does it exactly, so yeah.
Okay, so he's right. So the thing is that x is set to 0. X is of type integer. Now x will be 1. And then the assignment will run, a will be 1. But here, first, x was 1, x will be set to b, and then x will be added to by 1, and x will be 2. So a and b will be 1, x will be 2. So whenever you put it like this, it has priority over assignment. But if you put it like that, it doesn't have, the assignment has priority over the incrementation. Clear? In many situations also, they don't differentiate from each other because, okay, for example, if you don't have assignment here, okay, you're just adding them either like that or that, doesn't matter. But when it's with assignment, it's used with assignment, then, okay, the priority comes in. Okay. And you know, I think this one, no, the priority of multiplication over sum. Okay, so, and whenever you have parentheses, okay, you're giving the priority to the things that is inside the parentheses. Okay. So those were mathematical operators, but these are relational operators. Okay. And what are they? Equals, not equals, greater than or equal, less than or equal. So also you should be careful. Equal always is in the right side. So, and then you cannot put equal here and expect that it will do the same. It's a syntax error. For not equal, you have this one. In some languages, it's like this, or some languages, you like Python, you just write not, but you don't have them here. So these are your operators, and they return true or false, which is a Boolean data type, and it's written like this in a lowercase, unlike Python that you write it with capital letter. Logical operators, we have and, or, and not to create conditional expressions. Okay, so and is with this one, or is this one, and this is not. If you put only one and, then it will be bitwise operators. Okay, so if you put two, it's a conditional operator, it's a logical operator, but if you put one and, it will be bitwise operation, an and operator. Also for or here, it will be, if you put only one of these signs, and then you will have only bitwise operator. I'm not going in that direction, but just to let you know. The goal, normally in the slides, you will see some text written in green and some texts are written in red. And these are best practices, or the things that you need to avoid, the things that you need to follow. So when it's green, like here, it's better that you follow this. It's recommended. The goal is to write programs that work and that are easy to read and understand. Using parentheses help to clarify your intent and avoid errors coming from misunderstanding operator precedence. So you as yourself, you may know that, okay, this is the priority, I do it like that and that. You don't need to have parentheses. But another person or you, after a while, when you come back to your code, you may not know, okay, what did I do in the past? Okay, so in that, it's really recommended that we use parentheses to make it more readable, to avoid bugs and so on. Okay, if-else statement. You can write an if-else statement in C++ like this. You have if, parentheses, your expressions. If it's only one statement, you don't need these braces that you can see here. You just write it like one statement. The indentation in C++, as I said last week, is just for readability. It has no meaning. It's not like Python that, okay, you have to do indentation. But it's totally recommended. You need to do the indentation, but it's not a syntax error for you. So we have a statement here. So if I also write a statement here, it will work. If I write a statement here, it will work, but it's not readable. Okay. And then else statement. But if you have multiple statements, like here, you have to put braces to create a scope. Okay, and this is the scope of this if statement. Every variable that you define in this scope will not be recognized after that. If I define a variable here, that I cannot access that variable even in this else statement. Okay, so in C++, every braces that you create, you will create a scope, and everything that you define there belongs to that scope and nowhere else. It's not like Python that you could define a variable inside if-else statement or inside a for loop, and after that you still have that. Okay, don't confuse them. You can put your braces here, 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 wherever you want. Okay, but not recommended. it's better to follow a consistent programming style. So, for example, in our company, when I was working in Iran, even for one statement, we were putting this one, and we always had it in a separate line because it's more readable compared to if you put it here. Because you're adding one inter, and okay, your blocks are very easy to be followed and tracked. So in some companies, they may say, okay, no, we put that here. But okay, in every functions that you have, in every projects that you have, you should follow that style. Even if it's not a building error, it's not a syntax error, it's just for readability. So we said we have if-else statement, as you just saw, but we have a conditional operator. This is something, for example, we don't have in C++. How does it work? You have one expression here, a question mark, another expression, a colon, and another expression. The compiler would check the results of expression 1. If it's true, the output of this operator, this is our operator here, this operator will be expression 2, the results of expression 2. If it's expression 1 is false, the output will be expression 3. Clear? So if it's clear, what would be the results of Z here? So X is bigger than Y, no, it's false. Then Y would be the results for Z, which is 2, so Z will be 2. Clear? Okay. So switch statement. Again, this is something that we don't have, for example, in Python, but it's a very good statement. You have an expression, you have switch, you write a switch, and then your expression, you can write a switch with if-else statement too, but okay, it's more readable for some scenarios. It's defined for some specific scenarios. You cannot write all if-else statement with switch, but you can write switch with every if-else statement that you have. So how does it work? It says that, okay, it will check the value, the output of expression here with every case that we have in this switch, okay? So you have to put one braces here, these two, and you have multiple cases. If the expressions equals, it's just for equality, so it doesn't check greater or lower, okay? So if expression 1 equals to value 1, this statement will run till it can have multiple statements here too. So it doesn't have to be only one statement. And if it has multiple statements, it's not like if-else that you have to put a braces. Without creating a scope, you can have multiple statements here in this section, okay? But it requires a break at the end. Why? Because it's the moment that it will realize that it should go out of the switch statement. Okay, so you can have multiple statements or only one.
If you don't put the break for like value 1, for example, but then execute value 2 and break them.
Exactly. Okay. So this is one of the problem. The thing is that if you don't put break here, then okay, it will run this one till it sees another break. If it doesn't see any break, it will run all of them. So you have to put the break there, okay, because it doesn't have any scope either. But even this structure is written such that even if you put the scopes, it really needs a break statement to come out of the this statement, the switch statement, okay? But what is default? If none of these cases, you don't have to, by the way, you don't have to put the default statement there, but it's recommended, okay? But if none of these cases are true, then the default statement will run. So we can have also multiple statements here, and if none of them is true, it will run. But if you don't put break here, for example, here, okay, I didn't check this one, but I know at least for the last one, I'm sure that the default will run too. But you can check it yourself that, okay, if I don't, for example, value 2 is true, expression is equal to value 2, and then you don't put break here, okay? And then see if the default statement will run or not. No, the default statement will run in any case, because, no, it will run till here, till it sees the break. Yeah, till it sees the break, it will run. And if you don't put the break here, okay, the default will also run too. Okay. So, what would be the output here? Okay, I already said the answer. That's what I just said. Plus?
Oh, yeah, plus default.
Yeah. So the question came to my mind, but I didn't know that I could put it as a question here, but okay. But that shows that my mind always works the same way. So if you put 2 here, and then after, since there is no break statement here, it cannot go out of the switch, and then the default also runs too. What is wrong here? So if we are the enter, okay, I can explain. See out, you are writing in the output. Okay, for the beginning, I reiterate what we have in the codes, but later on you will master these things. See in, you are getting input from the user. So if it will, your cursor at the console will stay, wait for the operator to enter the value. Okay, this is see in. And then, okay, the operator will enter a value and the switch will run. If the operator enters 0, then do 0 will run. After that, the do 0 is just a function call. So you have a function defined somewhere with the name do 0, and it's calling that function. Okay, and then after that, all of them will run till here. The thing is that when you put this something like this, it's like that you are saying it's either 1, 2, 3, 4, 5, run this one. Okay, but since you didn't put also break here, it's as if that you write here. Yeah, it's as if that you also put 0 here. I mean, case 0 here and put the do 0. No, it's wrong. In any case, it's wrong. So you have to put break after this one. But if you want to have or between 1 to 5, you can write it like this. Okay.
Possible to write it with the operator or is one?
No, because this one it only checks equality. Okay, so the number, I mean, switch case is just doing like if the number equals 1, if the number equals 2, if the number equals 3.
So you can put if the number equals 1 or
no.
But you could maybe write an if statement just before the switch that tests if it's between 1 and 5, and outputs like a very specific number to then select the 2, 1, 2, 5.
Yeah, but this is not wrong. This area is correct. So if you really want to have or,
it's just very weird to write it like that. So yeah.
But this is correct. So if you want to have or inside switch case, you can write it like that, but it should be on purpose. Not like here that, okay, I can see from the definition of this code, okay, you wanted to just write do 0 and you forgot break there.
Is this better than a if condition?
Mm-hmm.
If you want to try multiple conditions that are the same results, is it better to do a if condition? It
depends. If it's just equality like this one, go for switch case because everyone knows how the switch case is implemented. You as a beginner, you may not know, but After a while, you will master the switch case. So if I want to read your code, I know that, okay, you're just checking the equality here. So it's designed for that. It makes your code more readable. But with if-else statement, I know that it can implement multiple different things, multiple different scenarios. So I have to read your code more carefully. Clear? But okay, you cannot do everything with switch case statement. So you have to use still if-else, but for other scenarios. You should, it should, after a while with your experience, it will come to your mind that, okay, I can write this one with switch case. I can write that one with if-else statement. The thing, for example, he's suggesting, what he's doing, he's trying to write if-else statement before, and then he has switch case afterward. But for me, as a person who wants to read the code, I should go back to see what's happening behind the switch case to be able to understand the switch case. Not much readable, you know, especially when your code gets very large, you're working in a company, okay, you know. So you can, the thing is that what we are trying to do here in this course is that to know, okay, what can we do better? Not just learning the syntax, because learning the syntax is not, it's very easy. You just Google and then I can write it like that. So you can ask.
In the case, if it searches an equality, so you could put anything. If it's an equality, it will do it anyway. So that you could make, for example, a list with a list number equals a number. It will do then.
You have to write a function there then, because you cannot compare list to list in C++. If we have, for example, vectors, you cannot compare vectors with a vector. You need to write a function to be able to do that. But normally, switch case is just for simple, operations like value, integer value, something like that. Okay. Okay, this is one exercise. I will explain it, but you don't do it now. At the end of the class, probably you will have time, and then I will check it, and you will do it. So you learned about enumeration constants last week. You will define an enumeration constant. You know, okay, which type of enumeration constant you should go. You go for class-based, not the plain enums. And you will define it for different types of error. Okay. One of the things, for example, we will expect you for your final project is to have error handling correctly there. We have different ways of error handling. You can throw an exception. You can just output one integer value. But the more readable one is to use enumerated constant. You will define a constant for every error types that you have, and you will return that one. And then at the end, for your user, you will convert it to a string type. Okay? And then, okay, your user, whenever that error happens, for example, it's wrong input data, your function returns an enumerated constant, but for your user, you will show the message that it should see from the conversion of that enumerated constant to a string. For the moment, step by step during the course, we will reach to that thing. But for the moment, just define an enumerated constant for different types of error. Just that. You don't need to write a function and those things. No. Initialize a variable by a value of your enum. Okay, you learned it last week. Implement a switch case to show an error message for each type of error. So, okay, you have to also do that one. But this is just, you don't have a function to use your error type, okay? But you have a switch case inside, and inside that switch case, you will convert your error type to a text, okay? How you can do that? You have a switch case that which your expression would be the input variable that you have here, okay? And your cases would be different values of your enumerated constant, okay? And for your switch case is just returning, for example, a text, a string message, or it's just a stdc out. For the moment, you can go just for a stdc out, because you will learn also in this lesson functions. We can already write a function and then you return a std string. Okay, we will do it together, so no problem. Inside one of the cases, this probably I will let you think about that and do it yourself. Inside one of the cases of your switch case, define and initialize an integer variable and print the value. I don't give you the answer of this one. It's very simple, but I want you to search for it and find it yourself. Okay, because as a programmer, you should be able to search and go for best practice. So not just, okay, the first thing that you see on a Stack Overflow, that's great. No, you need to check and see how people are talking about that, which one it should be better. Even I'm still doing that, because it's not, I mean, C++ is a very big language and it's getting updated every time. You may come to me and say, Nassan, I saw this one written in this link and it's better and I have to follow you. It's not like that, okay, I said, no, it's the best practice. Okay, we do that like that. So you should always update yourself, search for whatever you need to do, and then implement the thing. Okay. So functions. A function is a subprogram that can act on data and return a value. Probably you wrote a function in other languages, no? So we have global versus local functions. Last time I told you, when I was explaining the main functions, I told you, okay, above this area, it's a global area. People, I see from students that sometimes they define their variables there, their functions there. And I said, okay, we avoid that area because it's a shared data, because we don't want everyone has access to our stuff, you know? We want to have encapsulation. We want to have different levels of object-oriented programming. This is the case also here for everything that we have. When a program calls a function, this is your main function. You have one statement and you have function one. You're calling the function one, okay? What does the run of your program? It will go inside the function definition. It will run it till it sees a return statement, or the scope will end. If it's a void function, for example, the return type of the function, if void, it will just go out. Then the next statement runs, then it goes here, it will see that, okay, it's calling function 2. It goes inside function 2, this statement will run, it's calling function 3, it will go inside the function 3, it will return, it will follow here, and then come back. Okay, so it's like this. Recursively, it goes in, and then it will come back. Okay. So when a program calls a function, execution switch to the function, then resumes at the line after the function call. Okay, resumes here. The well-designed function performs a single, specific, and easily understood task identified by the function name. So it's important that you define a function not too big, not too small. If it's just doing one incrementation, that's too small. If it's a function doing multiple different tasks, it's too big, okay? You should learn that, okay, it should do a specific task that you can describe it by its name. Okay, complicated tasks should be broken down into multiple functions, and then each can be called in return. The thing is that if you always should think that, okay, these things that I'm implementing here, can I break it down to multiple different things? Okay, yes. Can I use it somewhere else? Okay, yes. So then it should be a separate function. Okay. So don't make unnecessary functions. Don't make too big functions. The header and body of a function. So this is the structure that we have for a function in C++. Here we have the name. Here we have the return type of the function. It can be any data type. It can be a class data type, or it can be void. When it's void, it means that it doesn't return anything. Okay, and then you don't need to write return a statement here because it's void. It will end when it sees the closing brace. If we have void, we don't have return, and it will end when we have closing brace. Okay. But if you have a return type here, you have to use return, otherwise your code will not be built. Okay. So then the name, and then we have the parameters. The signature, I mean, the functions are defined by their signature. The signature of the functions is their name plus their parameters. Which part of the parameters? Their data type and the number of parameters that we have, not their name. The name doesn't matter. Okay. What does it mean? So you can have two functions with the same name. One can have, for example, one parameter, the other one can have two parameters. Still, they are two different functions. Why? Because they are defined by their signature, and their signature is their name and their number of parameters and the type of their parameters. Clear? Everyone got it? Okay. So you have opening braces, closing braces. As I said, when we define a scope, whatever defined inside this scope belongs to that scope. After that, we don't have access to them. The same for these variables here. If I define them here, they will be destroyed when we have these closing braces, unless you pass them in any way. I will tell you later. But normally it's like, okay, the variables itself, they will be destroyed after these closing braces. Okay. Here. Compiler reads your code from top to bottom. Calling a function before its definition leads to compile error. Let's do something, and then you will see the problem. Open your Visual Studio and write your main function. I can also use any interpreter. Okay. You can see from the screen what I wrote here. So if I run this one, oh, but I need to call it. So I run this one. Yeah, you have to put this. So you see, there is no problem. I defined a function here, not recommended to defining, if it's not recommended to define a function here, okay? It's just for now in the class, I want to run an example, that's it. Don't do that. So I wrote a function above my main function. I called it, and I could I had no problem. I went inside the function and that's run. Okay. But if I put this one, now after this, I will have problem. Print message was not declared in this scope. It's what is written here. Compiler reads your code from top to bottom. Calling a function before its definition leads to compile error. Okay, so here I'm calling a function before its definition. Okay, how can we solve it? We can reorder them. We can bring it up, okay, as it was before. So I can bring the function before main, reorder the functions, and the problem will be solved. But it's impossible in some scenarios. A is calling B, B is calling A. Okay, then how can I reorder them? The best solution is forward declaration. What is forward declarations? A statement that tells the C++ compiler about an upcoming function. So you put the declaration of your function there. Okay, let me go back to this. This is the function definition. You have at top the signature, the return type, and then the body of the function. This is called function definition. This one is called function declaration. Okay, function declaration, it has the return type, the name, the parameters, the parameter name, and the parameter types, and one semicolon at the end. We didn't have that semicolon here. Okay, this is function declaration. So if I put now this one before this and put one semicolon here, it should not give me an error. This is called forward declaration. Okay. So with your forward declaration, you are saying to the compiler that the definition of this function comes later. And then you don't care about the ordering things and so on. But you will not do something like this in your code. What you do, you put your declaration in a header file, and you put your definition in a CPP file. Okay? And this is the case here. And you just include your header file in your main CPP file, for example. What does it do here? If you go inside IOStream, which since it's something inside the C++, I cannot go inside now. But if it was your file, you could go inside the header file. You will see that inside the header file, you have some declarations. Okay? And the definition is defined in another CPP file with the same name. So if you include it here, it's as if that you are putting the declaration of all those functions here. And then this part will be in the CPP file, which is the definition. So you don't do like that, but include will do the same for you. Okay? Clear? So we said that the functions are distinguished from each other based on their signature. Okay? So that means that we can define functions with the same name, but different parameters. So here, that's called overloading functions. Okay? So overloading means you have at least two functions with the same name, but different parameter types or different number of parameters. Okay? When do we use overloading? It's when, okay, the body of your functions, I mean, you have a function, you have a task, is the same. It's, for example, it's sorting, but the body is different. The body of the functions are different, but still they are doing the same task. The input is also different, okay? The input is different, the body is different, but they mentally, I don't know how to say that, but concept-wise, they are doing the same task, okay? Then you go for overloading. This is not recommended, what you see here in this slide. It's just as an example. Why it's not recommended? Because I can call this function also with integer values. Okay, they can be casted to each other and it can bring ambiguity. And because of that, I will receive some warnings and so on. So it's not recommended, but I just wanted to show you, you can define two functions like this, and they are receiving, since they have different data types, it can be syntax wise, you have no problem, but okay, not recommended. But overloading is something that people use. It's not something bad, but in a correct way. So you can test this one again at the end of the lesson. Let's go to the other one. Default parameters. You have default parameters in other languages like in Python too. So what does it mean? You define, this is your function declaration. Inside your function declaration, you can set some default values for your variables. How they work? You have to start from the right. So if you want to have a default value for parameter 2, you have to have a default value for parameter 3 too. So it's not possible to start from left. So these are all possible. And what does it mean? Whenever this function is called, the caller doesn't have to put a value for parameter 3 here. Here, it doesn't have to put a value for parameter 2 or parameter 3, which means that these variables will be set by their default value. Okay? Guess it's clear. Local variables and global variables. A local variable is a variable which defines a local in a local scope. Okay? When we define a scope with braces, that's called a local scope. And the local variable is local to that local scope. Okay. As I said, starting from the first lesson in C++, global variables are legal, but they are almost never used. Okay. Because they are shared data, because of encapsulation and so on. I already explained about scopes, about local variables. Can you guess what's happening here? Again, this is not a readable code. It's just for you to understand how difficult can it be to learn about the local scopes and so on. So you shouldn't do these things that you see here. Okay, starting from here, what we are doing. And then we are initializing it. X is 0. And then here, X is 20.
So you print 20.
And
then you define a new variable that you also call X, which is then 1. You print 1. And then you destroy the X that you initialized in the scope. And you print 0.
No.
Print 1.
Print 20.
Yeah, print 20, yeah.
So till here, it was working with X from the global, outer scope. But here you define the X again, and now it's always like that. It will go to the closer variable in the scopes, closer scopes that is defined, and then outer. And then, okay, X is 1, and then will be printed here as, I forgot your name. Ethan. So as Ethan said, this X will be destroyed. So whenever we have a closing braces, whatever we define inside that scope will be destroyed. Okay, and this is really important, especially when you have later pointers and so on. You should know, okay, that variable that you had, for example, inside that the scope is deleted, and then, okay, you don't have access to that memory. These are, so you may think, okay, it's a very simple thing now, but later it will come at a danger for you, okay? And again, as I said, you don't do these things and don't try to play it smart, you know, because sometimes trying to be very smart, very unique, it will cause so many bugs in the future for you, okay? Okay. Recursive functions. So you have factorial, for example, here. And let me see, what time is it? 9. I think the first one is more important. So if you want to write a function recursively, it's doable in C++ too. How we do that? We can do it like this. We had the definition here. This is factorial function. And we are saying that if, and this is if else statement, we have an if else statement here too, okay? If as n is 0, return 1, otherwise return n factorial of n minus 1. So it will go inside that till it will see 1 and it will recursively come back, okay? But one thing, I will talk about these things later, but since we are here, maybe it's good to point it out. You cannot have so many recursion here, because whenever you are doing this here, you are, every time you call this function, you will create this integer variable. So every time that factorial is called by a variable, by a value, it's as if that scope will be created again and again with the variables that is inside that. So what does it mean? For example, if you are calling now 10 times this factorial, it's as if that you are defining the n 10 times. So if it was, for example, 2 bytes of memory, you have now 20 bytes of memory. Okay, you should not think that, okay, it's just one function and that's it. But your stack, whatever that now you are defining here with these recursive functions, are inside your stack memory. And your stack is 1 megabytes of memory. It's a very limited number. Normally, it depends on the operating system, but normally it's around this number. Okay, so soon you can get a stack overflow. So you should be careful that, okay, you don't get a stack overflow with recursively calling the function. What is wrong here? I don't remember it even myself. Mm-hmm.
You pass data type instead of value to your function.
I pass what? Data type. Yeah, that's one of the mistakes. I didn't see myself, but there is one more.
You return a void.
Oh yeah.
Yeah. So yeah, one of the mistakes is here. Okay, that's too stupid to happen. To put a data type as input for your function, while you need to pass a value, an argument. And here my function has of type is of type void, which means that, okay, it cannot accept any return value. And now I'm returning a variable here. Okay, so it will not be built at all. Okay, clear everything till now? So we can switch to loops. So similar to other languages, we have loop statement here. We have while, for example, starting with while, we have, this is the structure of while. We can have two structures for while. The first one, we initialize the condition first. Okay, it can be, it can be any condition, while it works with any condition, okay? For me, it's just a counter now, but it can be other things. It can be a function there, whatever. But I have a counter here, I'm initializing them, and then I go inside, I check the condition first, and if the condition is okay, then the body of the while can run. Again, this is in a scope, whatever I define inside belongs to that scope. Okay, nothing has changed. The rule always stays the same for any structure you have, any scope that you have. So now I'm saying that, okay, counter plus plus, counter will be 1, and then print it. It will reiterate this one till it sees that, okay, counter is now 10, and 10 is not less than 10. So it will go outside of this scope here. I still have access to counter because counter is defined before while, okay? But if I define something inside, then I don't have them anymore. How about this one? This is do while, which means that at least the for loop will run once because the condition will be checked after the run of the body of the while, okay? So counter is 0, counter plus plus, show it, and now it will be checked. So even if it was, for example, counter was 20 here, counter would be 21, and I could have 21 at my output, and then after that it will be checked by 10, and it will go outside of the while. So do while will run at least once. That's the difference. How about here? What do you think? What will happen in this side? Exactly. So no, no, not exactly. Think more. There's a semicolon here.
I'm looking at that. I will just add one after.
Yeah, exactly. It will be an infinite loop because counter plus plus will not run. It will always try to check counter is, if counter is less than 5, yes, it is. Okay, another time, another time. So it will stuck there. Okay. Yeah, but if I didn't have this one and I had a scope here, okay, it would run correctly.
For the while, it's the same as the if. If you only have one statement line, you can drop the.
To be honest, I don't remember that if you have one statement for, because we always go for best practices and it's always like, okay, you put the statements, but you can test it yourself. Why? Yeah, it can be. Probably it will work with one statement too, but again, not recommended. Don't do that. Because you see, it will create many ambiguity for you. So we have continue, breaks, and return. These are the statements. You already saw breaks for switch case, but these are the statements you can work when you are when you have loops. What they do? Counter 0, counter equals 10, yes. If counter equals to 5, no. Counter plus plus, counter print, okay? And then it reiterates till it will see counter 5, continue. What does continue do here? Continue will not run the rest of the code. It will go back here, so it will stuck at 5. So it will always, because there is no incrementation. But what that shows the task of continue. The task of continue is that if you are in this iteration of the loop and you see the continue, don't run the rest of the body, go to the next iteration. But if your counter is out, counter plus your incrementation is after, it will not run. So you will always checking the counter with 5 after that. So this condition will be always true, and you will just reiterate same thing. Okay, this is a mistake. But another situation, you come here, counter is 0, counter is not equals to 5. Okay, show 0, but it will now stuck in 0 because it never sees counter plus plus. Okay, what I can do, I put here counter is 1, counter is equals to 5, no, and then it will reach at some point to 5. Counter is 5, yes. So 5 will be skipped. So you will not print 5 here. You will start 1, 2, 3, 4, and then 6, 5, 7, 8, 9. Because this one is after your continue. Clear? So continue will skip the rest of the body. This is the body of the while loop. Will skip the rest and goes immediately to the condition. Okay? How about the, oh, I didn't put the break. Okay. If we had break here, break will go outside of while. So it will go immediately here. So if it was break here, I had 1, 2, 3, 4, and then nothing. I will come after this while. Okay, and return. If I'm writing, for example, this while inside the main function, for example, if I write return, my program ends because it will return to the function, to the color of that function. Okay, if it while was defined inside a function and then I had return, it will return to the color of that function. For example, here, let me go back. If I have here, for example, a while loop inside this function, and inside while I put return, it will return to here. It will not run the rest of the while loop and the rest of the function. I guess it's clear for you. If you have any question, you can ask. Okay, for loops. So we learned about while loops. Now let's go for loops. In for loops, we have 3 sections: initialization, test, and then action. So this is the initialization that you had for a while loop. It was outside of the while loop. It didn't belong to the scope of while. And you had to increment it inside the while loop. But here, I belongs to the for scope. Okay, after this one, after this for statement, you don't have access to I anymore. Okay, I is defined inside for. This is the check statement, the condition, and this is the incrementation. But you can write whatever you want here. Okay, initialize a counting variable, test is the condition, action, increment, or decrement variable. This is the normal routine, but you can have other things there. As I said, the scope of I is just for the for loop itself. What is the output here? You can write it also like this, no problem.
So it's 1, 2, up to 4.
Mm-hmm. 1, 2, 4. It's as if that you are writing a while loop, not recommended, just to show you that how it would look like if you wanted to imitate what we have for while with a for statement. Okay, now its counter belongs to outside the color of for, so it's not only for itself, but if I put int counter here, then it belongs to for only. The counter plus plus it's inside for, but it could be here. So the routine is this, but you can even write it like that. Just to let you know, okay, if by any chance you read a code that someone wrote it like this, okay, you know. What about this one? This is statement.
Zero up to 4.
Exactly. So you have everything inside for, it's not like while that, okay, if you put semicolon, you are stuck, you definitely are stuck, okay? But here, no, if you have you define your conditions, yes, if you put nothing here in here and here, okay, you will stop. But in such a scenario, you are putting the body and the incrementation in the action state, okay? So you are defining the counter here, you are checking it, and you are printing it while you are also incrementing the variable. So no problem, it can run, but not recommended. Okay.
And would it be recommended to print out in the body of the for loop the y, the I, but at the same time incrementing it, like putting the SDC out
In the body.
in the body, but with the implementation in the C out.
If you put this one, if you put nothing like here, and you put this statement in the body, it will still work. Okay, similar to this one. You see, the counter is here, the print is also here. So you could put this one, you just put, you open it braces, you remove your semicolon, you put your scope here, and then you put this statement there in the body.
And in the previous example, by example, if you put instead of counter plus plus before the STDC out, but you do the counter plus plus in the STDC out.
Yeah, it will work.
Yeah, but is it something common or something?
No, don't do that. No, it's just to show you, no. Because you're making it more confusing again. More confusing for yourself. So keep it readable. Okay. And this is really not recommended. I mean, you shouldn't do this, but okay, you should know what things you have in C++, because somebody might write it like that for any reason. Or you or one of your colleagues by mistake, they do something like that there, and then, okay, you are saying, okay, what's happening? And then you can debug your code, your mistakes even. Because you don't get any build error for these things. So when you don't get any error, you may do a mistakes like that, and okay, at least you can trace back your code and understand what's happening. Okay, I did like that. Oh, okay, this one is defining this scope and this one is defining that scope. That's why it's behaving like that. Okay, how about this? So even this one is a statement. So it's doable in C++, but for sure, you will not write something like this. But okay, if suddenly you were developing your code and you wanted to write a for loop, you started to write this, and then you went out to have a coffee, you come back, you build your code will be built, and you don't know what happened, why it's stuck somewhere, what's happening to my code. And then you come back and say, I was writing this one, but I forgot to delete it, erase it. You know, so but if your eyes is not used to these mistakes, okay, mistakes like conceptually they are mistakes, but syntax wise they are not mistakes. You cannot find them. You want to?
There should be a semicolon after the for loop.
No, it doesn't need it. It can, but it is talks. It's nothing, really nothing. This one is correct. So you can either increment or decrement. What is wrong here in this one?
You're gonna look for oh no, you're not gonna do anything.
Everyone got it? You found it? Because counter is 100. So I never enter inside this, even if this one is written correctly, but okay, you had to put something here that let you go inside the function, inside the loop. How about here? What will be printed?
Don't you get an error because counter is defined in the scope of the for loop, and you end the scope of the for loop with your.
Yeah, that's true. But imagine that I define int counter outside, and then what will be printed?
Well, the counter that's defined before your for loop.
No.
9.
Hmm?
The number 9.
10. Because 10 is when it's wrong.
And then
Yeah.
starts with 4.
Yeah.
But why doesn't it use the counter of the for loop?
Hmm?
So, if you wrote counter before the for loop, and you said that like it's equal to 100, then you define a new counter in the for loop.
No, but imagine I don't have anything here, and I just put this one outside. It's nothing here. And what would be printed?
Okay, yeah, but counters shouldn't exist when you want to do cout.
If I define it before it exists.
Yeah, but in that situation, you define it in the scope of the for loop.
Yeah, here, yes, I told you it is correct. But if you, what you said in the beginning was correct completely. Yeah. So yes, I mean, let's make it clear for everyone. So now in this example, counter is not defined because there is a semicolon here. Counter is defined only inside for. Okay. So as Ethan said, counter doesn't exist. You will get a syntax error. Your code will not be built. Okay. But if you put counter, this definition, before for loop, and then you just run it with this semicolon here, what does it happen? It will iterate, it will counter is 0 first, and then counter plus plus 1, 2, 3, 4, 5, till it will seize counter 10. Counter 10 is the moment that the condition is wrong. It will come outside of the loop. When it comes outside of the loop, it will see stdc out counter. Okay, and that moment counter was 10, so 10 will be printed. But it's two different scenarios. But if I see this code, what I will understand is that, okay, it's a mistake. It should not have a semicolon here. It should have a scope here. So none of these scenarios, it's just, okay, I'm trying to give you different examples. At the end, when you see such a code, you should immediately say, this semicolon is wrong. I need to put two scopes here. Yeah, I mean, one scope. Because syntax, you understand that what the author of that code wanted to do, but there is a mistake. Okay. Okay. These are, you will do this at home. And then next week, I will show you the answer to these exercises. Again, there is no scores, but it's good for you to do it at home. And then we will check it together during the class next lessons. But what are they? You write a program in C++ to find the sum of this series in n terms. But write a function for doing that. Get a list of sorted numbers and a value. Check the value if the value is among that list. If so, return its position. To define it, since we didn't learn about the listed, let's go for arrays. Later on, we will learn about the standard template library and so on. But you can define just a variable define a variable like this as the input of your function. And this would be the values, just set it like that. You don't have to get it from the user, no. To access every items of this array, you need to use braces like this, and you can add them like this. So you get a list of sorted numbers, and then inside that you check if this element exists, this value exists, and if it exists, returns to its position. But think about it. Don't come up with the first answer, first solution that comes to your mind. Okay? Think how you should implement that and how it will be efficient. Okay? To be honest, all the slides are available on the website. You can even see the answers there, but please don't do that. Check it first. Think, okay, well, I have a list of sorted items. How can I find an item inside that? And then come up with a solution. Write a program which receives two variables of the same type and checks if they are equal or not. Consider why of the same type. Ah, yes, of the same type. Yes. Okay. You have a program that is going to compare two integer values and it's going to compare two string values. Okay. Write a program who will does that, which will does this for you. Okay. Okay. We will learn about function. What time is it? Maybe we can. Yeah, I think it's better that we come back. You implement this one, and I can put this on for next. Yeah, it will take time if I start with this one. Yeah. Okay, we put the function parameter and arguments for next week. And now instead we come back to this exercise that we had. Yeah, I think it was here. Define an enumeration constant for different types of errors. And then initialize a variable by a value of your enum. Then implement a switch case to show an error message of your each type of errors. Inside one of the cases of your switch case, define and initialize an integer variable and print the value. Okay? Do it now, such that I can help you if you have any questions. And if you find time, we will go back to the function parameters, but it depends how fast you implement this. If you have Visual Studio already, use it. If not, you can use this online interpreter that I shared last week with you.
I had a question about the error handling that you presented. How do you return an error statement if, like, your function should return an int value?
You just define inside your enumerated constant. You will define with just one enumerator. One constant, which has input with name input wrong input values, for example. Just like that. But you always later we will discuss. If I explain everything, you will be confused. You need to see it,
Okay.
But for the moment, you just define an enumerator class, and with different types of wrong input value, no error, wrong conversions, I don't know, whatever error that you get, just read for it, But I will show it to you in the next lessons. His finger crossed over the next one.
You never know.
Never know. That may help. Okay. Allora, ti questo e then for some later
I was
we'll-
making it, but I thought it was not necessary to do it now.
No, it's okay. They have time. It's good. I can show those to other people. Maybe. It's working. That's up. Which version?
2022.
Okay. Is it out? Ah, here. Read this one. This one more clear than the arrows itself. So, and you can just double click on that.
Just comment par email. T'as vu
It goes also to the
Ouais, mais c'est plus ou moins comme.
il faut juste écrire ça. Après, tu définis une liste.
Je vais faire comme sur la main.
Is it a good option to use 2022 or do we have to use 2017 for compatibility
The
reasons?
thing is that, okay, it's, I cannot say that it's necessary to use 2017, but I work with 2017, so if you have problems, probably I can help you there better than 2022, but no obligation.
Yeah, it's because I had already installed 2022 or something else, so
And I just said also to your friend that you, on every PC you can have different version of Visual Studio, so you can have 2015, 2017, and 2022 on your PC. So
Yeah, but I had problems with, I had another PC where I had 2019 on my PC and I wanted to switch to 2022. But even after installing 2019, there were like some residual files from that program and it caused problems later on, so yeah.
if you try to open a project that is created by 2015 in 2017, there you may have problems.
Oh, okay,
So you should avoid that.
okay.
But if you create a project, for example, in 2022, you still can open it with 2022.
Yeah,
yeah, so maybe you will not be able to open more programs if you
Yeah.
So we better.
okay.
Good reasoning. Yeah, I really suggest that we all go to the, for example, if you go to a company, they all will use the same version of IDE, such that, okay, if there is a problem, everyone can help each other. So maybe.
I should provide my email address or email will go to this one.
Okay, then we can start this one from the scratch on one of your what is the version of Visual Studio?
Je commence à avoir beaucoup de choses d'installer sur ce PC. Du coup,
I think you
installer encore dans Visual Studio. Et
Yeah, those are content too. So
Ouais, ça
you
reconditionne,
also
parce que j'en avais marre avec le Mac.
17, and then use the link that I shared in the Canvas with you.
Débrouillement.
Okay. But for the moment, you don't have to stick to this. You can go to online and write and search online compiler for C++. Yeah, the one that you already opened.
Windows est super bien.
Just write your code here for today.
Et t'as fait ton mail. Il faut un doc, tu es chez moi, c'est ça.
Yeah, but I have another one.
J'ai juste mis des belles trucs.
Ouais, non. Là, t'as un enum.
Ah,
On va
yes.
dire peut-être
You
de
need to
manière
find
plus
answers.
Research is for.
Yeah, just
Je
below.
l'ai initialisé à ce
How to
moment-là.
define
Je l'avais pas après.
I didn't teach you this.
Qu'est-ce que tu fais?
Did you write the rest?
Inside one. Oh. Okay.
How's it going to?
What should I do for initialize a variable like value?
I didn't teach you, you need to do it.
Ah, okay.
It's okay if you don't have answer for all the things that they are going to implement in this class. So
Okay.
does this work?
Voilà.
Yeah, but inside yours.
Yeah, but it's neat.
But you need to, okay, try.
Boom.
You can see the definition of ignorance and how we define them in the previous slides of last week. If you have them.
What does Qt do?
It's for GUI, writing your,
Oh.
but it's not only that, in some companies they use it for network communication, thread handling, but we will use it for GUI. You have the 2022.
Yeah.
So you all then switch to 2017 and then try to use my links.
Yeah.
And another thing is that is they try to find if there is a location that you need to stop updating of Qt. Okay, this is a problem that you will have because the version that you are using is old, but it matches 2017. But the problem is that Qt will try to update itself, and then you will have misalignment between the version of Qt and the version of your Visual Studio.
The access codes or what was it? You send some.
In the canvas.
So in the.
This is the license for Windows.
Yeah, but why do we
yes.
need the keys?
Yes, the keyboard installing Visual Studio.
Oh, yeah,
Yes.
we need a key for that.
These are the keys from Metro. The Windows is also for VVIP. Did you find all the answer for the second one? What was the answer?
By creating a scope in your switch.
So we said that, okay, we don't need the scope inside your switch case. We just have one for the bigger scope. But if you want to define a variable inside your case statement, then you have to define a scope there. And defining a scope means putting opening braces and closing braces. So, no question? Did you all implemented it?
Almost.
Almost? Okay, but we wait for you that you implemented completely. How about you? If you have time, you can already go for the next exercise that I told you to do it at home. I can go. If I put it, you have it, okay, I'll do that. Awesome. This one. This one. Copy this one because C++ is sensitive to the case of the letters. And then you need to put colon. No, erase this one. No, not that one. No problem. Erase from error to the end. And go back. You need to put the colon and write syntax level. There is this space before syntax. And there is one error. Put semicolon. Also here. So now we define a variable of type error. Okay? This is a type that you define, and these are the constants here.
since you put class here, you have to write this one before, because these belongs to the scope of this error type. If you don't put this one, you don't need to write it, but okay, it's not recommended, okay? So now go to the next one. You need to also write the main function. It's not like Python that you can immediately write something, okay? You write the main function, and then you define these two inside the main function. Okay? Try to follow the slides and learn the ones that we gave you last week, because otherwise soon the course will be a lot more difficult than this one. I don't want to make you afraid, but if you don't follow the course, you will have problems later. I recommend you start with the second one. The first one you can do it at home.
But again, it's your choice. What time is it? Yeah, with this one. And we will see the answer of these ones next week in the beginning of the lesson.
And something I didn't understand, I had 31 and I skipped it. The tree is just, I forgot to underline here. So it's nice.
Yeah. But these are, you know, the main function. Okay. But then you have to remove this. Right, that you put this one. You can also, I mean, the best thing is that you put both of them inside there, because this is your global area. And we try to avoid working in global area. Okay? So you have to put this line also inside. Now you have a data type and a variable type, and you're returning your zero. But it cannot do anything for you. But it should not give you any build error. Just run it. Let's Because you see, the syntax that you have here is without your T is lowercase 7, but the T here is uppercase 7. Yeah, exactly. So suppose it's there. Now, return, you wrote it wrong. So now you don't have any error, but you still need to do the rest of the assignment because you just define a variable. You need to write a switch case statement, and then also, yeah, also service. You click on enter, press. Yeah. Now here you are recursive, but go to the slides and see how we define a switch case statement. Which solutions you want to go for the second one?
Sorry?
For second one, how do you want to solve it?
Binary search.
But what would be the first solution that comes to your mind?
Yeah, you could do linear search, but it sorts itself.
This is the first.
Okay. You should think about the second one.
Yes.
How's it going to you?
I'm enjoying Zoom.
How you are going to solve it?
With Boolean. Yeah, if making definition function, Boolean function, and returning true or false.
No, the second one. It's going, you have to return the position of the element.
Oh yeah, so
Not
it's
just
true.
checking
Okay,
if it's a
okay.
list or not.
Sorry, so just the integer.
Okay. Okay, think more about it. But it's okay.
How do you initialize that you put the list as nothing?
That you put like here. So I wrote it there int, but it's really int star.
Oh yeah, that's.
But don't, yeah. Let me make it easier for you. Okay, let me write something for you here. That would be easier instead of work, because at the end we will not work with these arrays, and they are not recommended. Instead of using this one, okay, instead of using this one, go for really include vector. Okay, like this. Okay.
Yeah, we can't read it. It's too failed, but yeah.
You don't see it? I can write it down here, maybe. Wait. Okay, instead of this one, above your main function, you just write include vector. Okay. And inside that, when you want to define a variable of type vector, you write std, okay, without this, in lowercase, std vector of type int, okay? And this is your variable name. You can write, for example, my list, okay? And to initialize that, you can initialize it with a list of variables like this. Okay. It's easier to work with this one. And inside your function, you will just write, if you are going for a function, you didn't have to, but if you are going for a function, then this would be your input parameters. Okay. Got your name
it's a dynamic.
Exactly.
So we don't have the size.
No, you don't have to put the size. Can I know your name?
Yeah.
Yeah, you're a teammate with,
Yeah. Yes.
I cannot remember the names.
The three brain cells that I can remember. I will write this one in the chat for you because we have to stop the lesson. Just such that you have it. Chat. So you have the definition of vector. Next week, we will first check the answer to this exercise, so you can continue working on that at home, and then the rest of the course.
So I have a lot of class.
No problem. Okay, I need to stop recording. And try to